Hello, we're going to look at reflections in the coordinate plane. First, if we take 4, 2 and reflect it over the x-axis, it's going to reflect over this line. So if we go to the other side, it's going to be 4, negative 2. And now if we do that over the y-axis, we change our ladder reflection of the y-axis, and now it's negative 4, positive 2. Now, this gets a little trickier when we're reflecting it over x equals 1. X equals 1 is a vertical line that at 1, so all of these points, x is equal to 1. So as a little hint, if we have x equals some number, we know it's a vertical line. Y equals, it's a horizontal line. So when I reflect it over here, we count, now we move 4 to the right. So we have to go 4 more to the right to get to 5, 5. Now, if we are going to reflect it over y equals 2, that's the horizontal line, you count them out and you're going 4 or 3 and 3 down, you got to go 3 more, and you got it. It gets a little tougher when we're going to do y equals x. The y equals x line is a line with no y-intercept, or y-intercept of 0 and a slope of 1. It looks like this. So now, when we reflect it over this, remember reflections go over the perpendicular. So perpendicular, I don't really like that I put 2.5 here because it's 2.5 uh, diagonals. It's not really 2.5, so I'm going to erase it. It's 1, 2.5 diagonals, so we'll go 1, half, 1, 2 to get to our other point. It's negative 1, 4. Now, at this point, it's probably good to think, what's the relationship between these values and these values? We'll get to that later. Now, y equals negative x, if I reflect it over this, that's a slope of negative 1, and that's 1.5 diagonals. So if I go 1.5 more diagonals, perpendicular, oops, I went too fast, that's going to be 1, negative 4. So think about the relationship between these values and those values. All right, so now we're going to do this with a triangle. So take some time, try to figure this out, and when you're done, press play. If we reflect it, it should look like this. Does it preserve orientation? Well, our red one goes clockwise, our blue one goes counterclockwise. So we'd say no, it doesn't preserve it, or preserve means to hold on to or keep. No, it changes its orientation. Is it an isometry? Yes, because it stays the same size. All right, so if we reflect it over y equals x, this gets a little bit trickier. We draw on our line, and we count up how many diagonals in each direction and go over. Make sure you're perpendicular with the line, and you should have something like this. Now, let's think about rules. If we had 3, 2, it went to negative 3, 2. So what happened to our x? It just went from positive to negative. That's when we reflect over the y-axis. If we reflect over the x-axis, we have, it just changes the y values. Now, there's a couple other rules for y equals x and y equals negative x. For y equals x, we just changed the x and the y. For y equals negative x, we did that, but we also made them negative as well. All right, now from here on out, I think you can do the rest of the